This chorus have challenged Team Tekzilla to do something exciting with carbon dioxide, the old CO2, aka the gas that powers kegs.
Just like this, including the spiffy new Coors Light Home Draft cold draft beer done right at home. As most of you know, I don't drink, but I'll take any excuse to play with compressed or frozen gases, whether powering tools or overclocking CPUs. We know you've seen mini kegs before, but the whole point of the home draft is to not only fit in the fridge, but give you an even pour and keep the beer fresh in the fridge for up to 30 days. That's a big step up from the mini kegs of the past.
It's pretty simple. If it's not cold already, cool it in the fridge for 24 hours. Coors says that keeps the foam down. Remove the safety tab, twist open the CO2 cartridge, and flip the red lock tab. Now pour. So, sober boy, you're cooling a CPU with CO2?
Yes! Roughly at negative 109.3 degrees Fahrenheit, we're talking about frozen carbon dioxide. That's dry ice if you're in the Walmart applied to a CPU for overclocking, because apparently I need a new way to damage my CPUs while freezing fingers and cooling drinks, or perhaps setting a new personal overclocking record. Let us cut to our secret lab.
To the lab.
Hey everybody, we're back here in the workshop. Remember from the system days, we're going to play around with a little CO2. Why? Well, because it's there and because it's fun. A lot of people don't realize dry ice, basically CO2 in solid format. And notice two safety tips. One, I'm wearing the goggles, and two, I'm wearing gloves. This is about 109 degrees Fahrenheit, maybe a little colder. It starts to vaporize at negative 56 degrees Fahrenheit, which essentially means whenever you see smoke or you're getting your Mr. Wizard on in science class, what that actually is CO2 boiling off. It's about negative 56 degrees. You can see it boiling right there in the bottom of the tube. There it is. There's a little piece of dry ice down there. Now I'm wearing insulated gloves right here, and it has actually in the last 30 seconds gotten extremely difficult to hold. Now, that's rule number one. Do not grab dry ice with your bare hands. It's a fast way to get frostbite. It's a fast way to damage yourself. Number two, do not lick the dry ice. Number three, this is an open container. Now, if I put a, where'd that cap go? Hold on one second. You may notice I'm wearing my glasses and my safety helmet right now, because essentially what you do, if you seal CO2 in a, well, if you seal it in a container, it doesn't matter what the container is. The worst case scenario would be steel, plastic's not much better. You're essentially creating a bomb. That is bad. I will not put the cap on this because I will be grossly violating California state law and subjecting myself to abuse, but I will give you a little demo. We got a nice safe piece of Tupperware here, and watch as the gas expands until it basically burps. This is relatively benign. If you did this with a sealed container, like a screw top container, the plastic sides would probably blow out. If you did it with steel and a lot of dry ice, you could do some really serious damage. So don't build dry ice bombs. What we are going to have some fun with real quick, though, is overclocking. Nice thing about CO2, because it goes directly from a solid state to a gaseous state, there's no liquid state, it's not going to damage your computer or your electronics. Right now, though, we're going to take my poor, abused, water-clogged Core i7 right there. We're going to rip the water cooler right there. It's going to come off, and we're going to throw in a basically my beloved Zalman air cooler. I'm going to drop some dry ice on that and see how low we can drop the temperature of the CPU, then turn it up and see what happens. This is either going to work really, really well, or I'm going to be buying another motherboard this afternoon. So we got 170 megahertz, and even at idle, you're looking at ridiculous temperatures, 80 to 91 degrees Celsius, 100 degrees, and you are basically going into throttling to save the processor. Watch the core speed right here. I'm going to fire up Prime 95, which is a torture test to heat up the processor, and watch those numbers. Yeah, look, it's all the way down to 850 megahertz because I've exceeded the thermal safety level on the processor, which is automatically throttling back. So we're going to exit that before it blows up my computer, and I'm going to shut down. We're going to throw some dry ice on that and see what happens. Okay, you can see those two big chunks on the top right there. And right there, that's our dry ice right there, our super cold dry ice. And then all the copper that looks white, that's frost. That's frozen water. That's condensation that has turned into ice, which is soon going to drip onto my motherboard. The sad thing is it's not even overclocked right now. It's running a typical like 45-degree temperatures. So at the moment, I'm going to call this a curious experiment. I mean, look at the temperatures, like negative 6 degrees, 16 degrees, like 30 degrees down to the cooler. But the CPU is still running around 45 degrees centigrade. I want to get that thing out of there before it starts dripping condensation onto my motherboard and end up buying my third motherboard in 12 months, one of which was the motherboard's fault, one of which was my fault if, well, this damages my motherboard. So I gotta get busy. Be right back.